How can teams run trillion parameter language models on existing mixed GPU clusters without costly new hardware or deep vendor lock-in? Perplexity's research team has released TransferEngine and the surrounding pplx Garden toolkit as open source infrastructure for large language model systems. This provides a way to run models with up to 1 trillion parameters across mixed GPU clusters without locking into a single cloud provider or buying new GB200 class hardware. Modern deployments of mixture of experts models such as DeepSeek V3 with 671 billion parameters and Kimi K2 with 1 trillion parameters no longer fit on a single 8 GPU server. They must span multiple nodes, so the main constraint becomes the network fabric between GPUs. Here, the hardware landscape is fragmented. NVIDIA ConnectX 7 typically uses reliable connection transport with in-order delivery. AWS Elastic Fabric Adapter uses scalable, reliable datagram transport that is reliable but out of order. And a single GPU may need 4 network adapters at 100 gigabits per second or 2 at 200 gigabits per second to reach 400 gigabits per second. Existing libraries such as DeepEP, NVSHMem, Mooncake, and Nixel tend to optimize for one vendor and degrade or lack support on the other side. Perplexity's research team directly states in the research paper that there was no viable cross-provider solution for LLM inference before this work. TransferEngine addresses this by targeting only the intersection of guarantees across network interface controllers. It assumes that the underlying RDMA transport is reliable, but does not assume any ordering of messages. On top of this, it exposes one-sided write-im operations and an im counter primitive for completion notification. The library provides a minimal API in Rust. It offers two-sided send and receive for control messages and 3 main one-sided operations: submit single write, submit paged writes, and submit scatter, plus a submit barrier primitive for synchronization across a group of peers. A net address structure identifies peers, and an mrdesk structure describes registered memory regions. An alloc UVM watcher call creates a device-side watcher for CPU-GPU synchronization in advanced pipelines. Internally, TransferEngine spawns one worker thread per GPU and builds a domain group per GPU that coordinates between 1 and 4 RDMA network interface controllers. A single ConnectX 7 provides 400 gigabits per second. On EFA, the domain group aggregates 4 network adapters at 100 gigabits per second or 2 at 200 gigabits per second to reach the same bandwidth. The sharding logic knows about all network interface controllers and can split a transfer across them. Across hardware, the research team reports peak throughput of 400 gigabits per second on both NVIDIA ConnectX 7 and AWS EFA. This matches single platform solutions and confirms that the abstraction layer does not leave large performance on the table. TransferEngine ships as part of the pplx Garden repository on GitHub under an MIT license. The directory structure is straightforward. FabricLib contains the RDMA TransferEngine library. P2P all-to-all implements a mixture of experts all-to-all kernel. Python ext provides the Python extension module from the Rust core, and Python/pplx Garden contains the Python package code. The system requirements reflect a modern GPU cluster. Perplexity research team recommends Linux kernel 5.12 or newer for DMA BUF support, CUDA 12.8 or newer, libfabric, libibverbs, GDR copy, and an RDMA fabric with GPU Direct RDMA enabled. Each GPU should have at least one dedicated RDMA network interface controller. This table compares TransferEngine pplx Garden with 3 alternative systems: DeepEP, NVSHMem, and Mooncake. Here is the direct breakdown of the data. Primary role: TransferEngine is a flexible, portable point-to-point solution specifically for LLM systems. The alternatives are limited to niche roles. DeepEP handles mixture of experts (MOE) dispatch, NVSHMem handles generic memory sharing, and Mooncake handles cache distribution. Hardware focus. TransferEngine is designed to work on both NVIDIA ConnectX 7 and AWS EFA Elastic Fabric Adapter. The alternatives are either strictly tied to NVIDIA hardware, Deep EP, NVSH MEM, or specific RDMA network cards, Mooncake. EFA status, the main differentiator. TransferEngine is the only one with full support for AWS EFA, reaching peak speeds of 400 gigabits per second. Deep EP and Mooncake have no support for EFA, and NVSH MEM suffers severe degradation when used on it. Portability. Because of the hardware support mentioned above, TransferEngine is listed as cross-vendor portable with a single API. The others are described as vendor-specific, NVIDIA-centric, or lacking cross-provider support.